So here we have the explanation for FRQ number 3. So in this equation, in this FRQ, we have potassium sorbate KC6H7O2, and it's commonly added to diet, soft drinks as a preservative, and a stock solution is prepared, and a student titrates 45 milliliters of the stock solution with 1.25 molar HCl, and it tells you the Ka for the sorbic acid is 1.7 times 10 to negative 5. So we know we have a total equation of KC6H7O2 plus HCl produces C6H8O2 plus KCl. We can separate those into K plus C6H7O2 minus plus H plus Cl minus produces C6H8O2 plus K plus Cl minus, and the K and the Cl cancel out, and so then you have so you have your net ionic equation of C6H7O2 minus plus H plus produces C6H8O2. So it says you have a total of 29.95 milliliters of 1.25 hydrochloric acid to reach this equivalence point. And it says calculate the concentration of KC6H7O2 in the stock solution. So if you have 29.95 milliliters of 1.25 molar HCl, that means you have 1.25 moles in 1,000 milliliters. So then you multiply that, 29.95 times 1.25, and you divide it by 1,000, and you get 0.037 mole HCl. But at the equivalence point, moles of acid is equal to moles of base. So therefore, to the 1-to-1 ratio, you have 0.0374 moles of KC6H7O2. And 0.037 mole, but we need molarity, so we have to divide that by the amount of the stock solution that was titrated. So it says in the prompt 45 milliliters, so 0.05 liters, 0.045 liters, because molarity is in liters, and you divide those two, 0.0374 divided by 0.045, and you get 0.832 molar. And for C, it's asking at the equivalence point of the titration, it's measured to be 2.54. And which of the following indicators would be the best choice for determining the end point of the titration? So we have a pH that is measured to be 2.54. And you want your pKa to be as close as possible to the equivalence point of your titration. So thymol blue is the closest indicator available to the equivalence point of the titration. So that will be the best indicator, because that's what you want, the closest possible. So for D, it's saying calculate the pH at the half equivalence point. So we know that pH is equal to pKa, and at the very beginning of the prompt it says the value of Ka for sorbic acid is 1.7 times 10 to negative 5. So pKa is equal to the negative log of your Ka, and the negative log of our Ka is negative log 1.7 times 10 to negative 5. So that means we know the pKa is equal to 4.77. And since we know at the half equivalence point pH is equal to pKa, that means our pH is equal to 4.77. 7.